In this video, what I'd like to do is go through an example of calculating the molar mass of C2H6. And then once we calculate the molar mass of C2H6, then using that molar mass in a few conversion calculations. So the first thing that I'm going to do anytime we're calculating the molar mass is the mass of 1 mole. So I'm always going to start by writing out 1 mole of C2H6 is equal to. Now, technically the molar mass are just two pieces, the mole and the mass. So the way that we find the mass is we go to the periodic table, and there's 2 carbons. In this class, we're rounding to the nearest tenth. So 2 carbons at 12.0 each gives me 24. And then each hydrogen is always worth 1. So it's like going to Dollar Tree where everything's cost $1. So 1.0 times 6 is 6. So I have 24 from the carbons, 2 times 12. Plus another 6 from the hydrogens, that gives me a total of 30. So 1 mole of C2H6 is 30 grams of C2H6. Now technically that is the molar mass, the mass of 1 mole. If someone asked me to go get a mole of C2H6, I could go get 30 grams of it onto a balance, onto our quad beam balance, and I know I have 1 mole. But from previous discussions, we know that a mole is equal to a mass. That's what we just did, looked at the atomic weight on the periodic table. But a mole is also equal to a number, and it's a number of particles. So I can also write equals 6.02 e to the 23rd, and these particles, we have to figure out what they're going to be called. Are the particles going to be atoms? Are they individual atoms? Are they molecules, 2 nonmetals stuck together? Or formula units, a metal and a nonmetal? Well, here's my dividing line between the metals and the nonmetals. The metals on the left, the nonmetals on the right. So carbon is a nonmetal. So now we need to figure out what hydrogen is. Now hydrogen's the tricky one. It is the one that's on the left side of the periodic table that really belongs on the right side. We have to put them on the left side because hydrogen has 1 electron on the outside, so it has to go in column 1A, but it really belongs over on the right side. So hydrogen's a nonmetal, carbon is a nonmetal. Since they're both nonmetals bonded together, we call them molecules. So 1 mole is a mass, and in this case it's 30 grams from the atomic weight. 1 mole is a number, always the same number. We just have to figure out what the name is going to be called. And then finally, if we're dealing with a gas at standard temperature and pressure, then it's also a volume, and that volume is 22.4 liters. In this case, C2H6 is a gas. I've had some excellent questions regarding how do I know if it's a gas or not? Well, if it's oxygen, then we would know. If it's carbon dioxide, we would know. If you weren't sure whether it's a gas, you could just ask me, and I would be able to clarify whether the substance is a gas or not. So we end up with 4 conversion factors. 4 conversion factors. The mole, 30 grams, 6.02 e to the 23, and 22.4 liters. Now what we're going to do is use those 4 conversion factors in the next 3 questions. Anytime we are trying to convert units, how do I know that I'm converting units? Because I'm starting with liters, and they're asking me for moles. In the next question, I start with liters, and they're asking me for the mass. In the letter C, I'm starting with liters, and they're asking me for molecules. So in each one of these, they give me the units of something, and they ask me for the same thing, but a different set of units. In this case, we're always going to follow the same procedure. we're always going to write down what they give us. Whatever information they give us, we're going to write it down. So 11.2 liters of ethane, which is C2H6, I'm going to write down 11.2 liters of ethane. The second thing I'm going to do is I'm going to make an empty fraction. And now I'm going to take 2 pieces of these 4 and put them into the empty fraction in order to change from units of liters to units of moles. So I have units of liters right here. When that happens, I want to make sure I put units of liters. So of all of these that I'm picking up here, I want to find the one that has the same units and put that on the bottom. Well, the one that has the same units is 22.4 liters of C2H6. So I put that on the bottom. If this had said moles right here, I would have chosen 1 mole to go on the bottom. If it said grams right here, I would have chosen grams to go on the bottom. And if it said molecules, I would have chosen molecules. But they gave me 11.2 liters, so I chose liters to go on the bottom. Now the tricky part is, how do I know what goes on the top? I still have 3 choices. I could put a mole on the top, I could put grams on the top, or I could put molecules on the top. The way that I know is, what is the question asking for? It's asking for moles. So I'm going to put 1 mole of C2H6 on the top. This allows me to cross out liters of C2H6, and now I'm looking for a ratio that I can use. Well, 11.2 is half of 22.4, so that can reduce to 1 over 2. Now I end up with 1 times 1 divided by 2. That gives me 0.5, or 1/2. 0.5 moles of C2H6. So the question asked, if I have 11.2 liters of ethane, how many moles is that? 11.2 liters of ethane is a half of mole of ethane. The second one that we worked through is 11.2 liters of ethane. And we make our empty fraction. Notice it's the same process each time. What is the mass? Well, once again, how do I choose these 4 to go into these 2? Well, I'm going to match up the units. So I put 22.4 liters of ethane. And then they asked me for the mass. So on the top, I'm going to put 30.0 grams of ethane. Once again, the liters of ethane cross out. If this didn't cross out, then you just chose the wrong one and we need to switch it. 11.2 over 22.4 is a half. And now I have 1 times 30 is 30, and 30 divided by 2 is 15. 15.0 grams of ethane. Somebody asked, 11.2 liters of ethane has a mass of what? It has a mass of 15.0 grams. Those two are equivalent. 11.2 liters of ethane is equivalent to 15.0 grams of ethane. Just like 12 inches is equivalent to a foot. They are the same. 60 seconds is equivalent to 1 minute. 11.2 liters of ethane. Notice I'm always starting by just writing down what is given in the problem. So up here I've got 4 conversion factors. I choose the 1, 22.4 liters of ethane. And then I'm looking for molecules, so on the top we'll go 6.02 e to the 23rd molecules of ethane. The liters and ethane cross out. If they don't, then we just chose to put in the wrong one. 11.2 is a 1 over 2 ratio. And now we have 6.02 e to the 23rd. The way I deal with this is I just take the number in front and divide it by the 2. So I get 3.01, and then I just attach on the e to the 23rd molecules of ethane. If I would have divided or multiplied and this number came out with 2 digits to the left of the decimal, I would need to move that over and change that to a 24. Or if it came out with no non-zero digits, I would need to move the decimal to the right and change it to the 22nd. The rule is, with scientific notation, we always have one non-zero digit to the left of the decimal. So if that doesn't happen, you just need to move the decimal so that you have one non-zero digit. And if you move it to the left, this becomes a 24. If you move it to the right, that becomes a 22. I hope this helps in setting up the 4 conversion factors that we can use if you're dealing with a gas. If you're not dealing with a gas, there's really only 3 conversion factors. And then how we use those conversion factors to take what is given and convert it into what is asked for.